Greetings and welcome to the United States Transhumanist Party Virtual Enlightenment Salon. My name is Gennady Stolyarov II, and I am the chairman of the U.S. Transhumanist Party. Here we hold conversations with some of the world's leading thinkers in longevity, science, technology, philosophy, and politics. Like the philosophers of the Age of Enlightenment, we aim to connect every field of human endeavor and arrive at new insights to achieve longer lives, greater rationality, and the progress of our civilization.
Aging is a natural process,
but it's a process which hurts our health and well-being.
We are lucky to have longevity researchers developing rejuvenation therapies.
Welcome to TransVision 2025.
Our next speaker is President of Royal National Academy of Medicine in Spain and a specialist in internal medicine and medical oncology, leading Spanish medicine into the longevity era. And he's truly had many prestigious positions during his career, one that also includes being appointed by the Spanish Ministry of Health as head of the Comprehensive Cancer Plan. So please give a warm welcome to Mr. Eduardo Díaz-Rubio. Would you like to hear? Yeah. Would you like a mic?
Good evening. First of all, I would like to thank the organizer, José Luis Cordero and Maria Cordón, for inviting me to participate in this very interesting meeting. This is really an honor for me. I would like also to congratulate José Luis Cordero and David Wood for the success of their book, The Death of Death. Because it's a bestseller in several continents. I don't know how many editions they have, but anyway, it is very remarkable. Okay. This is the second year that I am here in this meeting. Last year, I were here to present my book, written in Spanish, Un viaje hacia la inmortalidad, a journey toward immortality. The reason why I wrote this book is because I am an oncologist and so interested in cancer cells. This book is really an essay that blends history, science, ethics, and futuristic speculation around immortality. I make an analysis about the immortal cell, especially to cancer cell, the HeLa cell, that you know very well, were obtained from a woman, Henrietta Lacks, in 1951, and that is really a great advance that produced a great benefit for the humanity. They were the first immortal cells, but there are other like stem cell, germinal cell, but on the contrary, there are mortal cells. And the mortal cells are the somatic one. In this book, I open also the door to the senescence, the cloning, cellular reprogramming, genetic edition, etc., with the clear objective, the approach, the longevity. But today, I am not here to talk about my book. This is a figure that you know very well, the life expectancy in Spain at the present time, 84 years, and in Madrid, in the region of Madrid, 86, being in women, 86, and 81 for men. But for many persons, the age is a burden too heavy to bear. For this reason, it is necessary to remain that for who the most important is to add life to years. In conclusion, we need to think about a healthy life. So in this context, it will be important to approach the role of academics. The Royal National Academy of Medicine in Spain, RAM, is an historical institution created in 1984, integrated in the Institute of Spain with a merit-based academic body committed to medical science. It's important to emphasize the values that is the independence, excellence, experience, transversality, and also meritocracy. So the question is, what can the academy do? I think that this is a good example, the document published by the German National Academy of Science, Leopoldina, recently in July 2025, entitled Health Extending Medicine in an Aging Society, and is focused on geroscience, providing scientific reflection, recommendation in the key areas, basic research, clinical trials, aging biomarkers, and regulatory framework. In summary, it supports the extension of healthy life beyond curing and treating diseases. So to ask the question, what can our academy do in the context of healthy life? I think that it will be necessary to generate a statement or principle, as the Leopoldina do. Make a call to the society, physicians, researchers, and also decision makers. And for that, what we need is to develop a project. We try to create a working group on geroscience. A working group, the objective and the principle of the group are the following: consolidate a multidisciplinary translational academic forum between the geroscience paradigm, having in mind that for us, geroscience is the science of the biological mechanism of aging and their link to the chronic disease. On the other hand, the principle that could guide the project should be: old age is not a disease, but it requires robust science. As I said before, not just longer life, but better life. Health span versus lifespan. And for that, what we need are clinical trials, robust clinical trials in aging, not only in age-related diseases. And of course, integrate molecular biology, clinical medicine, artificial intelligence, and public health. With this objective and principle, the project should be able to develop the following action. First of all, establish a roadmap for 2026 to 2030, create a working group with internal and external members, excellent members, experts, no more than 8-12 experts, and hold the first academic workshop, Geroscience and Health in the second half of life. And of course, produce a consensus paper, focus on research recommendation, a proposal of a pilot clinical trial, the definition of a national geroscience strategy. I think that it is very important. And finally, organize several thematic roundtables. The roundtables on geroscience and health in the second half of life will focus on 5 critical topics. First of all, the biological basis of human aging, geroscience and chronic diseases, current and future intervention, clinical and ethical dimension on healthy longevity, and public policies, communication, and medical education. There are the 5 roundtables I mentioned before. The first one, biological basis of human age, signaling pathway, epigenetic proteostasis and cellular senescence, animal model and translation to humans. The second one will analyze the relationship between aging and cancer, diabetes, cardiovascular disease, neurodegeneration, and other. For me, I think that this is really a priority because we need to control this disease. And finally, try to answer the question, can we delay or prevent multiple diseases with a single intervention that slows aging. The third roundtable will focus on candidate drugs, metformin, rapamycin, senolytic, incretins, NAT supplements, induced pluripotent stem cells, advanced therapies, analyze the ongoing studies and trials, and of course the role of diet, intermittent fasting, exercise, microbiota, mitochondrial health. The fourth roundtable focuses on clinical and ethical dimension, on healthy longevity, will consider precision and predictive medicine, impact on health system and equity in access to anti-aging therapy, and also aging biomarker differentiating by biological from chronological age. And finally, the fifth roundtable will be dedicated to public policies, communication, and medical education, training physicians in geroscience, the role of academic institutions in shaping a new vision of aging, and also implications for the longevity economy. In the final part, I would like to address a very sensitive but fundamental issue for the development of this project, the challenge and barriers. And in relation to that, it is important to have the commitment of the institution, its academic members, and also all the external experts. Most important is to get enough funding, drawing on national and European public funds, foundation, and companies with the aim of holding working group meeting, organizing roundtable, and produce document. And for that, I think that it will be necessary to have a project manager in geroscience. As conclusion, I would like to state Spain needs a national strategy on geroscience. And our academic can lead this project with independence, objectivity, and scientific excellence. The goal is not to just to live longer, but to live better in good health. But remember that at present time, this remains a project that requires approval and consolidation by the academic body. And finally, let me to emphasize 4 principles we cannot renounce: scientific rigor and independence, multidisciplinary collaboration, orientation toward impact on patient and society, and open science and transparency. To finish, I would like to remind you a phrase that, in my opinion, must remain in our minds. This phrase was written by Alvin Toffler, a sociologist, writer, and futurist, in his book, Future Shock, written in 1917, where he said, "The illiterate of the 21st century will not be those who cannot read or write, but those who cannot learn and relearn." Thank you very much for your attention.
Thank you so much to the President of the Royal National Academy of Medicine of Spain. I'm so proud that he's leading this important institution that on Friday will also give an award to Dr. Mahmoud Khan. I want to congratulate also Lars. I love this report. Can we distribute it to the people here and to the Mayor of Madrid who is coming tomorrow? Okay, fantastic. So we are going to give you the report. It's very nice. Well, you saw his presentation, and we will give it tomorrow to the Mayor of Madrid and later also to the President of the Community of Madrid. And we are waiting for the report of the Royal National Academy of Medicine of Spain. So we will present that next year. Okay, now let's continue with another doctor from Spain who is part of the organizing committee of this event. So we are very proud that Francisco Mera Cordero has been working with us for all this event, and he has been also coordinating the scientific part, and he is doing a fantastic presentation about longevity in Spain. He's an expert on longevity, COVID, and all of these things, and he has 8 minutes.
Thank you. Thank you very much. Thank you very much for all. My presentation without a slide. And I'm going to speak my experience and personal experience, like clinical practice and the research. The first, good afternoon, everyone. Today is a very special day for me. it has now been a year since we began the exciting task of collaborating of the organization of this event, dreaming of the moment we will be here together. My sincere gratitude to the authorities present for their support and endorsement. Thank you very much al Ilustre Colegio de Médicos de Madrid, especially to the Doctora María Cordón, to the media and the press for amplifying these ideas that can change the world, to the companies and investors whose commitments vital to turning science into reality, to the brilliant community of scientists and researchers who, with their daily work, are building the future of the longevity. And of course, to the general public, to all of you who, with your curiosity, energy, and presence give meaning to the gathering, welcome to TransVision 2025 Madrid. But there is one thank you that deserves a very special mention. I want to give thanks to José Luis Cordero, his tireless role in leading the revolution for the unique vision that of an engineer who analyzes the system of life and humanities who understand its profound meaning, has been and continues to be our compass. José Luis, your holistic vision inspired us all. Thank you for guiding us. In our precision unit, we have developed a comprehensive approach that moves beyond theoretical models to clinical implementation. We employ epigenetics testing to determine biological age of our patients. So DNA methylation using microbiome, mitochondrial function to access the cellular energy function, conduct comprehensive microbiome analysis and scan technology for real-time measurement of mineral status and toxic heavy accumulation. By analyzing data for all domains, we create a personalized therapy for our patients. In Spain, in this moment, there are different laboratories, companies, like Dr. Redden, dedicated to creating personalized serum therapy protocols for longevity, using compounds such as glutathione, NADH, curcumin, resveratrol, for improving the quality for getting of the health span. They bring me to the second crucial focus, the essential connection between health span and sustainability through fine sport perform. Fine sport represents a revolutionary approach by connecting through that ecosystem all participants, earth, fauna, flora, and humans. Data intelligence means AC for sustainability is not just a slogan. It's a platform for understanding how human health intersects with planetary health. For the place, all other focus are involving cutting edge is the research collaboration. Collaboration in this position in Madrid. I am proud to collaboration with the CBN, Severo Ochoa, with Dr. Cayetano Boncove, and I am studying about the senescent cells and working for production a vaccine in front of the senescent cells for improving the health span and for lack of high to try nothing to disease. Okay? We are conducting research relationship between accelerated aging and long COVID. Our project is mapping how post-viral syndromes can premature aging process. We are for the place novel vaccination technology, that could potentially slow aging process. This collaboration demonstrates Madrid's role, a global hub where clinical practice, sustainability integration, and groundbreaking research converge to create comprehensive solutions for healthy aging. Madrid has emerged as the completed longevity ecosystem where multiple innovation streams converge. Clinical, sustainability integration, research. We are demonstrating that the future of longevity medicine must encompass not just personal health span extension, but also planetary sustainability and cutting-edge research collaboration. TransVision 2025 represents the perfect platform to advance this integration, where clinicians, research, data science, and sustainability experts can come together to create comprehensive solutions for healthy aging on a healthy planet. Thank you very much. I look forward to our continued collaboration in building this integrated future of longevity medicine. Thank you very much.
Well, we have been working together, so I am so happy that Francisco talked about that. Really, really fantastic. By the way, I forgot to say something. In Madrid, we say, from Madrid to heaven. De Madrid al cielo. From Madrid to heaven. Remember that? Yes, thank you. Okay. Now we are ready. We are going to introduce George Church. And for that, we have, of course, our fantastic Master of Ceremony, Sabine von Gafke.
Our next keynote speaker is nothing more than a true legend when it comes to genomics and biotechnology. His innovations since back in the early 1980s have contributed to nearly all the next generation DNA sequencing methods and companies. In addition to his lab work on chip DNA synthesis, gene editing, and stem cells engineering. And this has all really resulted in foundational application-based companies spanning fields all through longevity and also medical diagnosis. From CRISPR to synthetic biology, Professor George Church's work has really reshaped what is possible in science. And Professor George Church couldn't be here physically, but we are so happy to have him here virtually. So, Mr. George Church, I hand over the word to you. A warm welcome to TransVision Longevity Summit here in Madrid.
It's a real pleasure to be at this TransVision 2025 in Madrid. I'm going to be talking about what we call ML squared for multiplex libraries plus AI machine learning. In particular, and applying that to 4 different kinds of therapies: protein, gene, cell, and organ therapies. And I'm going to try to do this in 20 minutes, so there's 10 minutes for Q&A. This is Longevity Day, October 1st, and I have many thank yous along the way, but in particular, at the bottom here is Personal Genome Project. Almost all the human subjects research, all the human tissues and genomes were from the Personal Genome Project, and it's your project. You can use it. It's freely available for commercial use if you want, international use, it's fully consented. And here's my financial conflict of interest in the lower right. It's a website. Okay, so I'm going to quickly go through how we developed analytic and synthetic tools, which you can think of as diagnostics and therapeutics. And in particular, we'll be focusing on gene therapies and aging initially. So here's 3 examples of analytic tools: nanopore sequencers, Illumina MGI, fluorescent sequencers, and then spatial omics that we've contributed to each of these things. And in the process, we've helped bring down the price of sequencing and synthesis by 20 million fold. And that includes moving from a poor human genome project goal, which was just 1 genome, to 2 genomes, diploid genomes in every human. So these are clinical grade in contrast. And now we have nearly perfect genomes of 6 billion base pairs per human. Now, that's the analytic side. On the synthetic and therapeutic side, I just want to bring to your attention, if you're not already aware, that there are affordable gene therapies. There are also multi-million dollars per dose gene therapies. That's mostly for rare diseases. But at the common end, so this is market size on the x-axis and factors of 10 for the cost, it plummets down to about $30 a dose. If you can get it to something like these COVID vaccines were all formulated as gene therapies, and hence 6 billion people benefited from them, and the price could come down. I think that's going to be true for both pandemics and anything that involves aging reversal. And in addition to affordability, which is important to us, we also want to have rapid feedback on the approval process for use in humans. And we have 2 really hopeful recent things. One was I was just alluding to was the COVID gene therapy type formulation, which was a brand new formulation, got an 11-month FDA approval, which is quite a bit better than the old days of 10 years. And then baby KJ went from a diagnosis, a whole genome sequence when he was born, to 7 months later having a cure, which has a name. The name of the drug actually has his name built into it, KJ, and the name of the editor, ABE, A-base editor, is a type of CRISPR that Musunura and Kieran and his colleagues published in New England Journal of Medicine. Anyway, I think that the gene therapies have this possibility of doing things inexpensively and with rapid approval. Now, we wanted to apply that to aging, and we didn't want to make any assumptions about biomarkers and so forth. We wanted to look at actual diseases of aging, age-related diseases. Now, the age-related disease is going to kill 90% of us, so it affects almost every disease. But we wanted those that were considered really characteristic of aging. We wanted to cure several different diseases at once to show that we were really getting at the core of aging. So we started with 48 gene therapies here in the upper right, and then focused in on 3 of them in various combinations. So the 3 that we picked were abbreviated A, T, and F for alpha-klotho, TGF-beta receptor, and FGF21. And they're color-coded, and they're in this diagram, this cartoon of going from the extracellular at the top through the bilayer to the cellular signaling to nuclear and mitochondrial components, all of which have impact. These are specifically aimed at aging signaling pathways. And we did 2 triple therapies. One is this one up at the extracellular, so it's being secreted into the blood, like young blood is known to be involved in aging. And then a triple factor, also famous from Nobel Prize Shinya Yamanaka, which we used 3 of the 4 factors, abbreviated O, S, and K. So A, T, and F, and O, S, and K are our 3 triple therapies that we finally got out of the 48 initial gene therapies that we tested. And this is mostly the work of Noah Davidson, who I'll mention in the next slide. So we tested these with disease models in animals, and now we're moving into human clinical trials. But we wanted to test as many diseases as we could. We started out with 4, and now we're up to 8 or so. For example, high-fat obesity induction, and we can restore that to normal with one of the combinations here, or 2 of the combinations, magenta in particular. And then insulin tolerance for a diabetes model, and then a kidney damage and restoration recovery. You can see at the day 0 where it's not damaged, and then at the end with 2 transcription factors, T and F, of the ATNF. And this is Noah Davidson. He was on these 3 papers, all of which used AAV, a viral delivery mechanism, and these 2 triple therapies in various subsets of them, ATF and OSK. In addition to these papers, he and I started his company, Rejuvenate Bio, which is bringing these into clinical trials, both veterinary and human clinical trials. Now, we don't go to the FDA talking about escape velocity or even longevity or de-aging, even though that is what we're interested in. We talk about age-related diseases. But we nevertheless, as part of those studies, we also do for our own edification, not necessarily for FDA, not required for FDA approval, is we look for survival curves. And I think these are the gold standard. If you don't have a survival curve, it's not clear that you're really working on longevity. You may be working on something else of medical significance. But anyway, these survival curves, we applied the drug very late in life. So some drugs people feel that you might have to apply at a very young age in order to prevent aging. But we did this very old, where half of the animals were dying for natural longevity-related causes. Nevertheless, when we apply it that late in life, we still got a very significant shift to the right. This is the blue line, which is the treated, and the black is the control. We're seeing about a 50% extension from that point forward, from that very late stage forward. And this was peer-reviewed in this cellular reprogramming paper 2 years ago. So that's Rejuvenate Bio. And then here's another one, like I said, the gold standard of these survival curves. And here's a survival curve. That was for OSK. That was one of our triple gene therapies. But we've also done a single gene therapy completely unrelated to either of the 2 triples I talked about from Rejuvenate. This is from a company called Regular Bio that my student, last one was Noah Davidson. This is Alex Plessa, published this paper. And here is the lifespan effect, where we're seeing a 14% effect or so from the single gene, which is equivalent in mouse years to human years. It's about 10-year human effect. And the same thing we see about the same sort of delay in onset of fragility. So you can see in these pictures, the one on the left is the control, and the one on the right is the animal treated with SRF1, which is a splicing factor. So the OSK were transcription factors, and the ATF were all blood-borne, liver-produced proteins. So different mechanisms, and we're getting, you can see how this sparse hair, gray hair, lots of fragility and grip strength and so forth. Behind the scenes in all of this is a lot of computing and AI, and I'll just give you an insight into that. We feel that AI alone is not giving us the answer, but when we combine it with large libraries, molecular libraries, they're kind of doing real-world computing, and the combination of the two is very powerful. So we can actually deliver 1 million different designs, AI-based designs. They're not random, they're not combinatorial, they're independent AI designs, inject them into a primate, as close to human as we can get, and then we can test all the tissue tropisms, all the different cell types that it goes to, its interaction with the immune system, and so forth. And we can do this for 1 million at once, which is very economical for whether we're doing a rodent or primate. Here we mutagenized every position of the delivery vector, the viral capsid protein, did all 700 and some amino acids, every possible substitution, where red means it's actually better at wild type at delivering that particular tissue. And so we can select for things that are, more abundant in heart or kidney and low abundance in liver, which is easy to get. And here are 5 of the first successes that we had. And I'll show you one in particular. BCAP1 is 100 times better at brain transduction than the previous best. So this is not relative to some random viral vector. This is AAV9, which was the best way of delivering to the brain before this study. We improved that 100-fold. You can see here on the far right. And in the process, we also detargeted the liver by 10-fold, which means we have to waste less money on the virus. We also have a lower toxicity because we use a lower dose to get it delivered. Now, again, this was the combination of machine learning to make the libraries and then the multiplex libraries to find the best, the ones that got to the brain the best. And we've done this for a variety of different tissues. And we've done it in 2 different species of primate to really make sure that it's going to be human relevant. This is thanks to Pierce and Eric, who published these 2 papers and co-founded Dino Therapeutics and have multiple collaborations on this. Just one last point on the AI here is that if we use a naive AI model or a random model, it's very hard to make these large libraries. We can focus in on a key surface region of the capsid that's going to determine where it goes, which tissue it goes to, and pick 28 amino acids in a row that are critical. If we take a naive model here in the lower left, we can hardly get any successful library members. But if we use logistic regression or some neural nets, we can get 26, 27, and 28 out of 28, essentially changing all the amino acids and still have functioning virus. This gives us great diversity so we can get new functionality, meaning new delivery in this case. That's what we can do with viral capsids for delivery. We can also do lipid nanoparticles if they have surface properties that we can engineer. And the nucleic acid is providing the barcode that tells us, that allows us to know who the winners were. So when we get a winner, we want to know what made it win, and then we use the barcodes for that. But in some cases, we don't want to have a virus or a lipid nanoparticle. We want to have a simpler peptide or protein, and for that, we want to have a small, innocuous, non-nucleic acid code. So here you can have a protein or a short peptide barcode, and these are synthetic, and we choose them so that we can easily detect them. So here's showing our detecting signal along the y-axis, and we can see very little off diagonal. The diagonal is very strong. Here's a blow up of it. We can make thousands of these barcodes with very clean detection, orthogonality with each other. So we can basically barcode as many proteins as we want. And we can use these for brain connectome and, more importantly, for Manifold Bio, who championed this or got this to work, to help co-found. We get tissue-specific medicines. So it's like the capsid story, except now with proteins rather than gene therapies. And here's an example where we got a 10,000-fold enrichment of one protein relative to random proteins in this screen. This is a screen using a humanized mouse, having the human transferrin receptor. And we showed that we really needed to do this screen in vivo. So again, this is a combination of the AI machine learning up front so that we get high diversity, but then we test it millions at a time in vivo. So I gave 2 examples of Dino and Manifold for gene therapy and protein therapy, respectively, but we have lots of other companies that have spun out of my lab, including Nabla, Helix Nano, Jura, Shape, and Lila.ai goes beyond therapeutics to science in general. And I'm very excited about Lila.ai. And many of these, essentially all of them, use this combination we call ML square for machine learning plus multiplex libraries. Then the final topic, and then we have time for questions, I hope, is on cell and organ therapies. We harnessed transcription factors and splicing factors, as you've seen. We can harness them so we can get up to 98% conversions from stem cells to our target cells in just 4 days. That we didn't know to expect that at the beginning, but it's what we've seen as what we should expect. And if we're not getting that, then we probably haven't worked hard enough to get the right recipe. We have now 300 different recipes to get different cell types, and we use RNA readouts, such as the one here, where we can just classify them broadly as endothelial neurons or fibroblasts, and then we can do subcategorize each of those for there's different endothelial and neurons depending on different parts of the body. And so we have these 300 recipes, and then a couple of them are making it now toward clinical trials. Here's an example of one where we have a recipe for making oligodendrocyte precursor cells. These oligodendrocytes wrap myelin around the axons to make rapid neural transmission that you have in your white matter. And this is what's demyelinated in autoimmune diseases like multiple sclerosis. We want to remyelinate it, but we don't want it to succumb to another round of autoimmune degradation. So we supplied them not only with this ability to remyelinate, but also production of cytokines which prevent the autoimmune attack. So these are, in a certain sense, super cells. They're better than the original cells. So we're not just doing a transplant. We're actually making an enhanced part of the brain. Now, the white matter makes about 40% of your brain. So this is a pretty important thing to be getting control of. And autoimmunity resistance is related to tolerance, which we've developed for transplants in general, and you'll see that in a moment. A second tissue type, so this is a oligodendrocyte tissue type with GC Therapeutics, and then two other companies that came from two of my graduate students here, Christian Kram and Merrick Smela, Gamito and Ovell, are trying to make either mature oocytes in the IVF clinics or make eggs from scratch. The first of these, the maturation, is now the first iPS-based therapy to be FDA approved, and it's now in phase 3 clinical trials. So this is looking very promising. It allows us to reduce the number of hormone shots from dozens by a factor of 3 and reduce the price by a factor of 3 as well. And then finally, so those were tissue types derived from human stem cells, but to get organs, we haven't yet, no one has made really large organs like kidney, heart, liver, and so forth. And so to do that, we need a full developmental system that's as close to human as is feasible. And so we chose pigs, in part because a number of groups before us saw the value of pigs being close physiologically and anatomically in size and so forth. And our first one is kidneys, but we're also doing liver and heart. But for kidneys, we have hundreds of thousands of people on dialysis. It's a very unpleasant experience. You're limited geographically where you can go. And also there's a brain fog that many of them experience. It's just the toxicity is not completely alleviated by the dialysis. We had a series of papers here, largely spearheaded by Mike Luhan Yang, who was a graduate student and a postdoc and a co-founder of eGenesis with me. We had to do 3 knockouts and 7 knock-ins, that is to say 7 transgenes that humanize the pig for all sorts of blood complement factors, blood clotting, innate immunity, inflammation. And moreover, the FDA was very worried about the endogenous retroviruses. These are things that could cause cancer or other problems. And in particular, since all transplants, even human to human, involve immune suppression, if you have all the pigs overproducing large amounts of these viruses in an immune suppressed patient, that is a recipe for a very unwanted possible outcome of evolving a zoonotic virus. So the FDA didn't want that. So we knocked them all out using CRISPR. And we were invited by the field, essentially by 3 of the founders of the field, to apply our CRISPR methods to these animals, multiplex editing, really. And we're not only trying to address the worldwide shortage of sufficient donor organs, but we were also trying to make enhancements, similar to that one enhancement I was talking about before of making them resistant to autoimmunity. We have animal examples of animals that are resistant to cold, dehydration, to DNA damage, to multiple pathogens, cancer, and senescence. We're trying to transfer these into the pig germline so that we can get better and better organs that are be better than anything you could get from humans. So, for example, here's a list of, dozens of human-specific pathogens which our pigs are not susceptible to. We'd like to extend this list to include all pathogens, but we're not there yet. This is a video of our longest xenotransplant so far. This is this 69 edited pig kidney. You can see the MGH surgeons transplanting it into Tim Andrews. And then we have a second patient. So Tim was in January, so he's 8 months. And then Bill Stewart, another New Hampshire man, was transferred in June. And they're both off dialysis and very happy about it. And I just want to open it up for questions and thank everybody. Again, thank the Personal Genome Project, which was the inspiration and the source of the cells and the data for a lot of the human experiments. And then this is some lab alumni. So thank you.
Dr. George, we are so happy, thrilled to have you here. And we are running out of time, so I just have one question, because I'm very interested also in the extinction. The extinction. You worked on the dire wolf, now the dodo, next the mammoth. What is the potential of those technologies for longevity?
Yes, so that project, the Colossal Project, is an excellent testbed for developing our developmental biology tools, and aging is a component of developmental biology. It's an epigenetic program where rodents die about a year and bowhead whales live for 200 years. So it's genetics and epigenetics, and we're getting a lot of insight into that, into rescuing endangered species and other things that we're doing at Colossal. Also, they're funding some of the work that we're doing on new reproductive technologies I talked about and multiplex editing, which I think is going to be key for all of the gene therapies that we're talking about. We're using in combinations and various sorts. That's, you can think of as multiplex gene therapies. So yes, it's very synergistic, the projects we do in Colossal and the other projects we do that are now making it into human clinical trials.
Thank you so much, and we wish you to win the Nobel Prize in Medicine very soon, Dr. George.
Thank you for your enthusiasm.
So our next keynote speaker is an experienced, knowledgeable, and well-versed doctor in the longevity sphere. Dr. Andrea Maier is a physician scientist, a longevity doctor, and founding president of the Healthy Longevity Medicine Society, and also founder of Chi Longevity. And her work in Singapore and globally is focused on bringing aging biology into clinical practice, really transforming longevity from theory into medical reality. Please give it up for Andrea Maier.
I'm a geriatrician. Most of the times I say, can you hear me? Can you see me? It seems to be all right now. Good. Thank you so much for being here. Wonderful building. Jose, thank you so much. I think you asked me 3 times, and then I said, okay, I cannot neglect you anymore. I have to come. And I'm really honored to be here. You're really a magic figure, the star in this space, and not that you want to be that star in the end, but... And you said that I do non-political comments. I think, as Aubrey, I learned it, I think, from the best, and that's Aubrey de Grey, to be sometimes not political. Sometimes I can be political, so I can also serve you in that way. But anyway, we are going from mice to humans, and I would love to tell you a little bit where we are in the space of precision geromedicine. Hands up, who knows what precision geromedicine is? Okay, a couple. Who knows what healthy longevity medicine is? Okay. Okay, so healthy longevity medicine is a new specialty within the medical arena to optimize the health and health span from aging individuals. And I used the term with many of other colleagues for 5 years now, and we were calling ourselves healthy longevity medicine physicians. And I always got the question, Andrea, don't you have a Latin word? Like, it's not sexy enough, it's not attractive enough. And so we said, okay, I had a good glass of wine with Guido Kromer in lovely Paris, and we said, okay, we have to change the wording. And we came up with precision geromedicine. Why is this, I think, a good term? Because everybody knows what precision medicine is. That's a new arena of medicine. So now we are putting gero in front of it. And gero is aging or age, depends on which school you have. And hence, it's precision aging medicine. And hopefully we will attract many more, and also the FDA and the EMA, with this new term. I have a couple of disclosures. I'm quite proud to be the founding president of the Healthy Longevity Medicine Society. I also think that all of us here should be a member of the Biomarkers of Aging Consortium, and I'm also quite proud to be involved in the Academy for Health and Lifespan Research. This is, at least in theory, what we are doing at this moment in time. In a couple of countries, we are already doing that, and it's a framework. How do we bring all the knowledge of geroscience into human studies, into clinical practice, and then into public health? I fully agree with Aubrey de Grey saying we know enough, let's translate. Because we're fixing mice, and Aubrey's showing that, and others too, that we actually can fix mice at this moment in time. They can live 20-30% longer. So if we have that knowledge, how do we actually transfer that into humans? And the time is ripe. 16 years ago, I wrote my first business case while I was working as an internal medicine specialist in Amsterdam UMC, which is an academic clinic in a hospital in the Netherlands. I wrote the first business case for an early warning clinic, which was then the term, I thought, for a healthy longevity medicine clinic. It was hugely rejected, hugely. Say, you are so stupid. Why should somebody look at me being healthy, come to a clinic and do a checkup? Now it changed. Now we have the translation and we have randomized controlled trials, and I will showcase you a couple we are doing, and we can introduce that into clinics, and we already did that. In 2023, in August, in Singapore, we opened the first publicly funded longevity clinic in a publicly funded hospital. It's occurring. The time is there. We are doing it. And I think we will really revolutionize the healthcare system. If everybody is aging, and I think most of us will agree to that, that nobody's escaping at this moment in time, we have a huge problem. Because 100% there should actually have access to these kind of new treatments and to diagnostics. And we are absolutely not there yet. We don't have the infrastructure to do that. So I think in the end, we really should have a public health approach. Hence, in Singapore, we are already working on the transition into family medicine and into GP care. What we really have to do, and it's really dear to my heart, of having pipetted so many fibroblasts in my life, we have to go from invention to real innovation. What really matters for the client in the moment, this time? Because then we are attracting the audience. And not just with interventions which have no evidence, but how do we actually implement the evidence-based approaches in terms of gerodiagnostics and gerotherapeutics into clinical care, that we are actually making now a difference to individuals' lives. And I can tell you, while having many clinics, yes, you can do that. You can lower the biological age of individuals at this moment in time. What do we need? I think we need a network. We are needing a network not just of scientists and healthcare professionals, which we actually did in the past decade. We really need to have policymakers included. So hopefully many of you also are policymakers here. We need industry partners. When I grew up in the academic system 20 years ago, we would never have collaborations with industry. Now in my center in Singapore, we always have collaborations with industry because we have to shape the future together, because in the end we need products for the end consumer. The consumer is hugely important. We are signing the first MOU now with a patient organization next week in Singapore. And it's not only one patient organization, for example, of endocrinology or of cancers or whatever we have, but with the alliance of APAC. And I think that's the first step, to really include the end customers in the discussion we should have, how we should shape the future of healthcare. And not only healthcare, but I would say of health. To do that, we have to publish, of course, a lot. We need new outlets. And of course, there are very, very good journals like Nature Aging, Lancet Healthy Longevity, etc. But there was really no journal being equipped for clinicians to write, for example, case reports. I learn every day in my clinical practice, and because I see individuals, and it's the NS1 approach. What I learned as an epidemiologist and from randomized controlled trials very often does not apply to my NS1 patient. So now we have the new journal, Geromedicine, we were finding with Hans Maier and Guido Krömer, and to really also allow these kind of really being seen non-scientific approaches to just explore what that case really meant, to shape the future of precision geromedicine. And a lovely article which might be interesting for you is the vocabulary of geromedicine, so the gero vocabulary, where we really can understand how do we define at this moment in time, which can change, of course, but at least it's on paper, gerodiagnostics and gerotherapeutics. We are launching next week the NUS Academy for Healthy Longevity, the trial center. We're already running trials for now years. However, we now have dedicated space, a huge trial center with the lab, with imaging facilities, everything to the highest standard at the NUS in Singapore. And you see that we not only do clinical research, but we also do clinical implementation. We have healthy longevity medicine clinics aligned to that, and we have now a network that also clinics send us their samples. What's very dear to my heart is education. How can we build an infrastructure to serve 100% of the population if nobody is trained? I always called myself a healthy longevity medicine physician. I think I'm totally wrong, and I'm not using that word anymore, and also not using precision geromedicine physician, because we even have not defined what that is. And there really the Healthy Longevity Medicine Society kicks in because we are defining it. But we have to educate. We have to educate youngsters. We are not attractive yet for the students. We are not in the high schools yet to really showcase what we could do and actually showcases that they understand why their parents are aging. So hence we have a talent incubator in Singapore. We have intensive courses. We all are CME accredited. We are building the master at the moment. We have executive courses, and the education programs and the training are running very well. And we have many educators now in the field, and hopefully we will replicate that in other countries. This is just an example that you should have fun while creating a new specialty. This is our Healthy Longevity Talent Incubator. If you have youngsters in your companies or in your universities, in your clinics, please send them to us. Go to our website and you will find how to apply for the Talent Incubator. And that incubators, we have 40 most talented people around the globe we are selecting quite heavily. We are bringing 40 to Singapore for 2 weeks of a boot camp, and we did that now for a couple of years, and then they are forming alumni classes. And very often they are now around the globe, and they're forming that very, very strong network of having the basis of geromedicine and geroscience, and now helping each other and really form the next generation of talents. This is an important paper I would like to draw your attention to. It's now published for a couple of months, where actually we looked at the hallmarks of aging and we described how that could actually help to bring it into the geromedicine arena, to couple this with age-related diseases. And this paper, From Geroscience to Geromedicine, it's called, we really describe how the next generation of physicians should be trained, what kind of trials we need, what kind of regulatory actions we should actually have. And here we describe it's right. It's the right time now to act, to bring geromedicine to flourishing. And we are doing that since a couple of years in Singapore, and this is our framework. We are really building the framework out of geroscience. We understand the hallmarks of aging. We have to bring geroscience markers into biomarkers of aging that we can actually not only measure by autophagy, for example, in mice samples, but now also in human samples. How do we actually measure aging, except of having epigenetic clocks, etc. So here the biomarkers of aging, being biological, clinical, and digital, are very important. Linking them towards gerotherapeutics, that we can actually measure the impact of interventions, is very important. Then you see we want to establish many more healthy longevity medicine clinics, which are in a network of academic hospitals, to educate and to learn and to write the guidelines. We will then push into the GP practices and family medicine practices, which in Singapore is called Healthier SG. I already told you a little bit about the Healthy Longevity Medicine Society, which we founded now 3.5 years ago, Eva Bishop and myself. And the first thing we said is, okay, we need a definition of what we do. It doesn't matter if in the next years this definition is changed. However, now we have to have one voice being strong. And we defined healthy longevity medicine as optimizing health and health span by targeting aging processes across the lifespan, which is then also very different from conventional medicine, treating diseases. It's very different from preventative medicine, which is very often based on the layer of annual health screenings. So we are targeting aging process, and we have to understand how we measure it and how we antagonize it. And very importantly, is we are not excluding anybody. We're only excluding, at the moment, children, because we do not yet understand, I think, the biology of aging and development to the point that we can translate that into clinical practice. But everybody with age-related diseases is welcome. You don't have to be healthy to come to healthy longevity medicine clinics, because also the ones with age-related diseases are still still aging. If you want to learn more, we have a conference, so we have an intensive course. So in February, it's always our week of lots of engagement, and there you will also see how the government and industry partners are interplaying with the NUS Academy for Healthy Longevity. So it's education together with network forming, hopefully seeing you in Singapore. I want to touch a little bit on biomarkers of aging and then a couple of trials we are doing that and still being in time. And I will only showcase you either studies which are not yet published or which have been published recently. This is an important slide I always show. We have to matchmake diagnostics with therapeutics. I think longevity clinics who just have an a la carte menu, this is the therapeutics you can get in our clinics, are not longevity clinics. If a patient is coming or a person is coming to my clinic and say, I want chemotherapy, I as a physician will never give chemotherapy if that person has no cancer. And I think it's so logic. Why should I get a stem cell therapy without any diagnostics? And that's happening at this moment in time in the longevity field. So that's the reason why we are really advocating diagnose what the pace of aging is, have good biomarkers, and then link that based on the origin of the physiology or pathophysiology to an intervention, and then measure again and measure what the outcome is. Steve Forward already showed you this very nice slide. I think it's really a hallmark paper in Cell 2023, where we defined what the biomarkers of aging are: molecular, physiological, and digital. We clinicians always say it's biological, clinical, and digital. Does not matter. It's the same content. And here you see that we forgot one thing, and that's actually the genome. We included the microbiome, epigenome, proteomics, and all omics approaches, but we very often were not talking about genes. Hence, we were defining in a different paper, which was published in Nature Medicine 2024, Geroscience and gerosuppressors, to really guide clinicians what kind of genes to measure in the field of geromedicine. We want to translate the biomarkers into clinical practice. And while I am a physician working in this space, I always ask myself, what kind of clock should I apply? And I get many emails of fellow physicians saying, what should I actually do? Which company should I use? And I think the only proper answer to that is, I don't know yet. We first have to investigate that. Hence, we were starting the Global Epigenetic Systematic Review Consortium. We have now 50 very, very talented, especially young people working in this consortium, where we only have one question. Which DNA methylation clock is associated with what? And the what is on the right-hand side, being given all the outcomes we actually measured. We have more than 30 ongoing topics to just answer the question, is a higher DNA methylation clock using a certain algorithm associated with either frailty, mortality, cancer, or whatever? And they are doing the analysis. And here you see the first results, which are now under review, already published. DNA methylation clocks are associated cross-sectionally with more frailty. I will showcase you it in a second. Lower physical activity, higher risk of cancer, higher cardiovascular diseases, etc. So now we are building that evidence base to then also give advice to physicians or to other fellow researchers. Here you see the detail. And this paper was published or accepted recently in Lancet Healthy Longevity. On the left-hand side, you see the methodology. Many, many, many papers, especially the epigenetic field, is bombardingly increasing. It's so nice to see. We were finding more than 1,200 articles, primary articles, to be included in the systematic review. It's unhuman to do this. None of the students will ever do that. So we have AI machines also helping us, but we had to segment actually the association studies into segments. And therewith we have the association with the cardiovascular system, with frailty, etc. And here I'm showcasing you DNA methylation clocks associations with frailty. There is, so we included 12 studies, so not really many at all yet. And on the right-hand side, you see the meta-analysis. And what we were able to find is that cross-sectionally, DNA methylation clocks, the pheno-age, the grim-age, and the pace of aging are associated with frailty. But this is cross-sectionally. If we are looking longitudinally, it's a little bit different. First of all, the number of studies are even smaller. The number of individuals are not as high, and what we were able to see that's only the grim age, and I think Steve Forward will be very, very happy with that, is associated longitudinally with the incidence of frailty, whereas the other ones were either non-significant or really went to the other direction even. So grim age seems to be the best one. So, but should I now say everybody should measure grim age? And of course, nobody should listen to me. We should form consortia to really build that agreement. Therefore, the Healthy Longevity Medicine Society came together with the Biomarkers of Aging Consortium, and we were forming that consortium to really write the guidelines for clinicians and advise them what to do. You see the individuals here listed, being included. Many of them are also in this room. And we were writing the first standard. If epigenetic clocks measured by DNA methylation should be included into clinical care. Here you see the result. So the summary of all the evidence we found in the literature using proper techniques. And what you can see, most associations are there with the second generation clocks. And Steve Forward already lovely told you yesterday what second generation clocks are. For example, the Grim H2 is one of them. So now we have the standard, and we have the paper is nearly ready to advise clinicians to use at this moment in time the second generation clocks, which are actually trained to predict mortality. But we should not forget other biomarkers of aging. I just show you here biomarkers of female reproductive aging, which was published, I think, a week ago. We very often, clinicians, forget to look either in the mouse, oral health, or think about the male or female reproductive aging. And when we were starting all our trials and we wanted to look at all organ systems and physiological systems, there were no protocols. Hence, we were writing lots of papers in the past years to actually summarize what it is. And this is the latest, a consensus guideline, how to measure female reproductive aging in randomized controlled trials, which could also serve actually longevity clinics to implement it into clinical practice. We also very often, we have no standards actually to do randomized controlled trials and include digital biomarkers of aging. Therefore, the Biomarkers of Aging Consortium was working on a standard, what actually digital biomarkers of aging are. What is the definition of it? And you see it on the left-hand side. But also very importantly, what is already used in clinical trials, and not in the longevity space, but really in the cardiovascular, endocrine, etc. space, what we could actually borrow and use for our trials. And you see that summarized on the right-hand side. So I think the time is really ripe not only to use it in clinical practice. All my patients have actually digital devices, and we can track them real time, that my healthcare coaches can actually tell patients what to do or not to do, or nudge them into certain directions. But we should absolutely not forget to use these digital biomarkers in our trials. And that brings me to my last section. These are the trials which are ongoing. We are recruiting at this moment in time at the NUS Academy. And one of them already finished is the ABLE study, where we are giving alpha-ketoglutarate to 40 to 60-year-olds, which are healthy. But we're also investing in multivitamin minerals. We are doing multimodal interventions now, where we are combining lifestyle interventions together with nutraceuticals and even drugs like GLP-1 receptor agonists or SGLT2 inhibitors. And we also look at how can we matchmake it to the gerodiagnostics. Who should we actually include? And we have a consumer survey model, which is the HALO study, and the clinical models, that's the HEAL study, where we already implemented it into clinical care. Just a snapshot about alpha-ketoglutarate. It's a very powerful molecule, or could be a powerful molecule, to actually reshape our epigenetic makeup and outer mitochondrial function, and therewith could influence many of these organs which are depicted here. When we were starting the ABLE study, we said, okay, we want middle-aged individuals, which is our prime target in our trials. And we said, okay, should we include everybody? Or could we actually enrich the chance that we would see something a positive result if we would only include the ones who are healthy, but they are biological older. So there was having a propensity of a risk of an age-related disease later in life. And later in life, most of the times it's in the next coming years when you're 40 to 60. And hence we were the first, only including individuals with a biologically older, measured by 4 different epigenetic clocks individuals compared to their chronological age. So in the ABLE study, we only included 40 to 60-year-olds with no chronic diseases, but being biologically older, measured by DNA methylation, compared to their chronological age. And we did that because we started 3 years ago now, did that based on 2 first-generation clocks and 2 second-generation clocks, which is also our outcome. Here you see the EKG design, 60 individuals, placebo versus a gram of alpha-ketoglutarate, lots of outcome parameters, and the primary one was the median of 4 epigenetic clocks. Recruitment is going very well. I got the criticism in the beginning, you will never be able to find biologically older, healthy individuals being 40 to 60. I said, why? Like 50% should be older, at least. And I would say, and hopefully not everybody has age-related diseases, but you can see within a year time we had the recruitment and everybody was happy being in the study. You see here a little bit more the detail of recruitment. You first have to screen the ones being in the trial design phase here. It's really relatively easy to find these individuals 40 to 60 because these are also the ones who want to come to longevity clinics. So in the end, roughly, we included from screening to inclusion 25% of the individuals. And I think that's quite good. I did other studies in my life where I was only able to include 1% or 10% of the individuals. Here you also see that the randomization went quite well. Alpha-ketoglutarate versus placebo. All the measures are the same between the groups. And very importantly, the median DNA age is higher, of course, compared to their chronological age being 50. And there were roughly biologically 54 to 55. Not many adverse events, no dropouts. So also here showcasing that I think we have a highly motivated group of biologically older individuals who really want to make this work. And if there are adverse events, it's the same in both groups. Very good adherence. More than 93% had a pill adherence of at least 80%, which is the characteristic in the trials, which means that it went well, and it's the same in the placebo versus the control arm. Here you see the main result. It worked a little bit. So we took individuals and they took 6 months of 1 gram of alpha-ketoglutarate, and we did the responder analysis. And what you can see in the upper panel is that we had many, many more responders in the AKG group compared to the placebo group, defined as at least 1.5 years of biological age reduction, using again the same markers while being in the AKG group. It really worked well in individuals who were already weller, who had at least, for example, 6,000 steps a day. So here we see really that finding the right individuals of the right needs for the right intervention is of utmost importance. Unfortunately, all our secondary outcome parameters are not different between the groups. So if we are looking at cognition, or we are looking at muscle strength or muscle mass or endurance, we measured all the organ systems. There were no significant differences. However, biologically, on molecular level, we see it, but not on clinical level, which means either we have to give higher dosages or we have to treat individuals for longer. So recruitment is feasible, limited adverse events. It works on biological level, and secondary outcomes are not there. The last thing, we have to mix up our interventions and do multimodal interventions. If you're looking at conventional medicine, very often we don't do that. I'm a geriatrician, hence all my patients have many drugs, and all the drug interventions and possible interactions have never been studied. I think we have to be smarter and better. And the first time that we are doing that in our group is in our XPRIZE study, Prometheus, where we are including, following the XPRIZE alignment, 50 to 80-year-old, which can have age-related diseases. And what we have chosen, we are doing a foundational intervention, looking at sleep, dietary intervention, soy protein, we are giving creatine, we are giving fucoidin, and we are giving exercise with exergaming next to that. And then based on the ageotype of individuals, we are adding either drugs, you're seeing them on the right-hand side, or end nutraceuticals, other nutraceuticals like NMN and fucoidin, etc. And the primary outcomes is being given by the XPRIZE. And here you see how it looks like. The study is only 2 months. So we are screening individuals, we are doing the assessments, and based on their ageotype, we are giving the ratios and the type of drugs, the type of nutraceuticals, and all get the lifestyle interventions. And then after 4 weeks, we are measuring again, and based on the ageotype, and if they increased or not increased, we are adapting, as you would normally do in clinical practice, our regime. So, and that could end up with people having NMN, having urolithin A, having a GLP-1 receptor agonist, etc. Everything is scripted, which means there's none of the decisions we are going to make which is unscripted. So hence, we can also then transfer that into clinical practice, into guidelines. We are recruiting and we are doing the intervention at the moment, and in December, everybody is out, and in January, we will have the results. So, Geroscience, great. I think we are there to translate. We have to define gerodiagnostics, therapeutics, and I think we are ready to really shake up the healthcare system to implement precision geromedicine. Thank you.
The lovely lady in blue. Could we put on the mic, please?
Thank you, Andrea, very much for that great presentation. I just want to know, you worked on that paper, on the Viadrina paper for the German government.
Yes.
And I want to know, in that paper, you, the first time ever, you mentioned aging as a disease for the German government, and to make sure that they understand that concept.
Yeah.
To make and that's a great approach. What do you think? How big are the chances?
In Singapore, everybody is aware of what you are doing, and you get a lot of funding and a lot of support. But unfortunately, I don't see that in Germany, and I don't see that in Europe. So what do you think? How long does it take that they understand as well that this is necessary, what you're doing?
So I'm super positive for Germany. I was not a year ago. Now I am. The Leopoldina brought us together, and we wrote that manuscript, a document, within 2 months. And there's lots of attention with the media. I was recently in Halle, like 3 weeks ago, and 2 deans of medical schools approached me, and this is in Berlin, and that's in Halle. We want healthy longevity medicine clinics. So they are now, right now, implementing it not only into the curriculum, but also they already have space to implement it. So it's hugely changing. I'm with governments at the moment in Germany. I think due to my origin, having a German passport, they now are hugely focusing on it. So Germany, I would say, compared to other countries, is absolutely at the forefront in Europe. So no, it's sums up. Germany got it.
Germany is at the forefront of Europe. Any more questions? Seize the momentum. Did Stephen? Yeah? Did we have a mic? Or you have a loud voice? You're close to us.
Yeah, I think your efforts for promoting geromedicine are really remarkable. I really love the work of human clinical trials as opposed to mice. Can you comment on when will we find out the results about fucoidin supplementation?
Okay, so the question is, when do we hear about fucoidin? So fucoidin, brown seaweed, is in our oceans, and we know that Japanese people live longer, hence we think SIRT6 activator might actually help for humans. We are recruiting, at this moment in time, we have the first participants in there. We are only doing that in 50 to 80-year-old males, being peripheral, because we know from studies in mice that especially it worked in peripheral mice compared to younger mice. So we are translating that at the moment in 6 months' time, you will have the results.
Thank you so much. Please give it up for Andrea Maier. So, hopefully you're feeling energized, your minds are open, your hearts are open, and you're really energized for this next session. And with that, it's time to hand over to our third speaker of this session, who is investor and founder of Human Longevity and Rejuvenation Syndication, and also strong advocate for longevity benefits. Please give it up for Ken Scott.
Okay, so Jose and this organization are very much into immortality, and I'm going to talk this morning about therapies that I think will help us achieve that immortality. I think of it as a road that stretches way out there to the horizon, and we're all on that road, and that road starts with our birth, or perhaps, if you prefer, our conception. And where's the next stop, the next signpost on that road? I suggest it's probably out there 80 years. That's sort of our expected life expectancy. And so I ask a question, and I can't see the audience, but I wonder how many here have completed 80 turns around the sun. Can I get a show of hands? Can somebody tell me how many? Is it just Helga? Helga and me? Perhaps. Only 4% of the population, or 4% of the population in the United States, and it's the same in most developed countries, is over the age of 80. Only about 1% of the population can actually look after themselves. 75% of the people have a need for care. What's the next stop? Well, let's not go another 80, let's go another 20. Where are we at 100? Turns out that at 100 years, we only have about 0.03% of our population alive. That's 3 people in 10,000. Ooh, what about the next 20 years? 120. Whoops, nobody there. That's the problem that we have with immortality. So what I'm going to do this morning is talk to you about some of the things that we can do to achieve the rejuvenation, which is really the only solution to immortality. And we've had a couple of speakers already talk to us about Yamanaka and the Yamanaka factors and the proof that we can take old cells and make them young, and the challenge is to do that for a whole body. But until we can do that, what do we do? So I'm going to talk to you about some of the therapies that I have taken, which I think are very effective. And they're sort of in 3 areas of intervention. First of all, I'm going to talk about peptides. And I'm going to mention, first of all, that peptides are very small proteins. I think you probably all know that, less than 50 amino acids. And the 3 that I'm going to talk about are the Cavensin peptides, some peptides that come from OneSkin, OSO1, and also some fairly new peptides, BCP157 and TD500. The Cavensin peptides I've been taking for about 5 years. I take 2 capsules a day for 10 days of the month. I take 5 different ones. You can see on the chart perhaps that there's a mixture of about 21. We vary those typically from month to month. And you can see some of the results there. Yesterday, Maria Blasco was talking about telomere length. And you can see the effect of these therapies on my telomere length, which has improved. We had talks by Andrea a few minutes ago about biological age. You can see some evidence that I had some biological age improvement. It works. OneSkin's peptide. OneSkin has a peptide for the skin. I should have mentioned that the Cavensin peptides will come if you take them with a warning that they're not suitable for human consumption. They're for animal experiments only. I don't know why we pick on animals. I take them. OneSkin has a peptide that they put into a skin cream, and cosmetics are not controlled by governments the way internal consumption is. I was involved in the original trial of this product about 4 or 5 years ago. I've been using it ever since. And this is a little picture from the first, I think, 90 or 120 days. And you can see the effect of that OneSkin peptide on my skin. You can see the effect around the eye where it removed the age marks. And you can see the effect around the mouth where it significantly reduced the wrinkling and so on. I won't talk about the last peptide, the BCP 100 or 157 and the 500. We're still working on those. It's a work in progress at the moment, but it has had amazing impact on the condition of my wife who suffers from dementia. Going on, we talk about the follistatin gene therapy that comes from minicircle. This is a plasmid. It's about basically encoded with the gene for follistatin. It's injected into the abdomen or into the muscles. Got a problem here, let me see. And what it does, of course, is it produces follistatin. It's a serum-based follistatin. It gets into the muscles, and it has some very interesting potential. It will strengthen your muscles, and it will also improve bone density. And so, yeah, okay, so it's in the blood, as I say. And here are some results, and I don't know how visible those graphs are. They're not bad. Okay, so first of all, you can see some bone density. It's sort of floating around, but at least mostly it isn't decreasing. But you'll notice that after 2 years, we're sort of back to baseline. There's an increase in the fat-free mass, muscle mass. I weigh about 55 kilograms, and my lean muscle mass increased by 2 kilograms. And that increase has stayed, although other aspects of the therapy sort of decreased after 2 years. You can see here more dramatically on the left, the increase in the follistatin 344 levels really soared over the first year, but after 2 years, we're back down to baseline. And I actually had another injection of the follistatin therapy about 2 months ago. In another month, we'll see how the blood serum FST level is. And then on the right, you can see how the epigenetic age decreased. And Andrea, you might find this interesting because I went from, I think, 71 to 18 for a little bit of time. And that's, I think, a world record in decreasing biological age. The next therapy I want to talk to you about is what we call V cells, very small embryonic-like stem cells. And these are taken from the blood, and the procedure is to take about 80 cc's of blood, spin it down to get the PRP, irradiate the PRP with lights of a certain frequency to activate the stem cells that are in the PRP. And these are stem cells that we all have in our blood all our lives, but they become inactive during the embryonic stage of development, and they can be reactivated by this light. And so then what we do is we re-inject this activated PRP, typically intravenously as a systemic treatment. I also have had it on injected into my knee in addition. And one of the other things that we've done is we take some of these stem cells and we nebulize them, and we actually inhale them into our lungs so that we're getting those stem cells going right into the pulmonary system. And here are some images associated with that kind of treatment. In the first one, you can see that I am standing there with a light being directed at my body. The light that you can see is not the active light, it's a targeting light. But essentially what's happening here is we're trying to attract the stem cells into a particular part of the body. And one of the treatments that I had about a year ago was really impressive. I had an injury to my right knee from jogging on a sandy beach 45 years ago. And like some of those injuries, over time it was getting worse. It was really bothering me. And so we did this treatment and we targeted my knee. And 4 days later, it was back to normal. And I have no knee problems now, a year later. In the middle photo, you can see me breathing the nebulized B cells. And then on the right, you can see that the B cells are being injected by a needle. One of the things that's happened to me over the last few years is I've become rather vain. I like to have facials occasionally. I got new teeth. I'm happy to smile. You know, look good, feel young. And so that's what we're doing on the right-hand side. I've had a couple of those facials. But what's on the horizon? I'm telling you about things I've done. Oh, by the way, I should say that all of these treatments I'm doing simultaneously, which relates back to what Aubrey was talking about earlier today, where he was talking about simultaneous tests with mice and how sad it was that we didn't do those kinds of tests. Well, I do it as a human, and there are quite a number of my friends who are doing the same thing. As we go, well, I guess the other thing I should say is that the follistatin is not approved anywhere, but you can get it in Panama at a clinic that I'm involved with. I actually got it the first time in Prospera in Honduras. And the B cells you can get in some places, but it's very important that any doctor who gives them not claim any results are possible. So what do we have coming up? Well, first of all, we've got some, and this is important for older people, we need to be concerned about our eyes, and there are a couple of treatments that are either available or coming soon. LentoBio have an eye drop which will increase the elasticity of the lens, which will, we hope, all of our tests so far indicate the lens elasticity will improve and will stay, so that you would probably take this for maybe 3 months or so and then do that every 2 or 3 years. Also, you can use allogebrium to counteract the effect of cataracts. My wife has done that quite successfully. In the dental area, the Japanese are doing some really important stuff. They're actually regenerating teeth from stem cell treatments in the mouth. And, you know, we've got to get rid of this dentistry stuff. For atherosclerosis, Cyclarity is doing human trials, clinical trials at the moment in Australia, and Repair Biotechnology, who have a enzyme that will catabolize atherosclerotic plaque, probably will do those tests in the next 3 to 6 months. I will be one of the first recipients. We've got a new mix of gene therapy coming out from Triple Helix. It will be a combination of follistatin, Clotho, and SIRT1. It will be delivered by an AAV vector. I will probably get that, as Helga will, sometime in the next 3 months. This will be, because it's an AAV vector, we would expect the results to last several years. The other thing that's coming up, which is really exciting, and there was a comment on this yesterday, I believe, and this relates to mitochondrial replacement, the idea of taking young mitochondria and creating a batch of them using bioreactors, and then turning that and injecting it into the body to replace the aging mitochondria. Both Helga and I have had our mitochondrial DNA damage levels measured, which is quite interesting. And then, of course, we have the transfection of the OSK factors, and this is being worked on by Age Reversal Network under Bill Falloon. So these are things that are coming. What are my conclusions from all this? Well, first of all, although the mitochondrial and the OSK transfection are out there and hopefully coming, and maybe it will start happening in the next year or two, I need to do things in the meantime. I need to provide nutrition to my body, and I believe that my body knows how to use the transitions, or the impact of the nutritions that we give it through systemic injections. I really believe that the mind knows how to handle the allocation of those resources. And so I believe that my body is actually being rejuvenated gradually. And you can judge for yourself, of course, and I want to show you how. I apologize that there's no sound. This is Bill Haley and the Comets, back from the 1952 era when I was a teenager. But you can see, that's Helga. In the previous one, it was Helga and I dancing, and you can see that I do a lot of other interventions at the same time. Now, I think, and I go back to Aubrey's comments a few minutes earlier, where he was saying that you're interested not only in numbers, but you're interested in how does the specimen look and how does the specimen act. And I believe this demonstrates that I am, in fact, rejuvenating. And that rejuvenation presumably qualifies me for the X Prize. And going on from that, you might say, well, who is this crazy old guy who does all these therapies that are not approved by this, that, or the other government, and who goes anywhere to do it? So let me just tell you a little bit about myself. So in the longevity field, we've seen in recent years quite a massive increase in the number of longevity experts, okay? And so I don't have a PhD in bio. I'm a mathematician by training. I'm not an MD. I've done a few things in my life. In recent years, I've been focused more on the biotech field. As I said, I was in the OneSkin test. I present at conferences. I've been a test subject for MiniCircle. I'm an investor in startup companies in the biotech space. I'm an advisor. I'm a biohacker. So I claim to be a longevity expert. And the qualification that I offer you is my birth year. And if you've got experts talking to you who are half my age, don't take it too seriously. Now, if any of this interests you, I am writing a book, and you can go there and register. I'm hoping it will come out sometime in the next 2 or 3 months. And I think I've tried to talk as quickly as Juan Carlos. I knew I couldn't present this in Spanish at anywhere near that speed, and I was told I had to be very careful about not exceeding my 15 minutes. So there we are.
And thank you also for, being an advocate for human trials, as i.e. yourself, because it's always interesting to sort of see over correlation of longer time, but you're also doing certain therapies that aren't even FDA approved, which...
I would say that human trials are incredibly important, but I also am concerned about ageism. One of the problems we have with the few human-type activities that go on now is that, as Andrea was talking about some of the stuff they're doing, it's on people who are 40 to 60 years old. It's ageism. Those of us who are over 80 need a little more attention.
Very true. Because, thank you. Being an aging demographic in the world, I think is very important.
Okay, we are very lucky in Spain because we have had a previous week of another fantastic activity called Longevity Biotech Fellowship. And during that week, there were about 100 people from all over the world who are interested in longevity and how to do something now. And there were fantastic speakers and advisors, and one of them is a very young guy, which I admire because he's so young and energetic, and he will be tonight at the Madrid Longevity Rape Party. I actually know his father also, but Dylan is the new generation, and Dylan Livingston, who lives now in the Washington area, he's doing the best lobby ever in the planet. He's lobbying for the government of the USA to open up its mind and to begin looking into longevity as an opportunity for investment, for growth, and for health. Because I like to say, health is wealth. And so with that, I truly want to invite Dylan Livingston to present about his incredible advancements in science.
Well, first, I'd like to say thank you to Jose and the TransVision Madrid community for allowing me to speak and for putting on such a wonderful conference in such a beautiful hall. This is, we don't get this in DC. We get a lot of corporate buildings, so this is a breath of fresh air. So I will tell you a little bit about my personal journey into longevity. I'll tell you a little bit about the work that the Alliance for Longevity Initiatives does. And then kind of go into the economics of longevity and why this really is the opportunity of a lifetime for investors, for governments, for the general population, because as Jose said, health equals wealth, right? So A little bit about me. So who are we as A4LI? We are a 501c4 nonprofit organization based in the United States, focused on representing the longevity biotech and overall longevity community's interests with legislators, with government officials, agencies, etc. We were established in 2022. I can't believe it's already been 3 years. Time is flying. We got to work on this longevity stuff because it's going too fast. Our mission is to advance legislation that extends healthy lifespan on Capitol Hill via advancements in longevity biotech, via advancements in sensible solutions to Medicare and health insurance and the entire kit and caboodle. But my personal interest here is in longevity biotech. So that's where we do a lot of our work and that's where we focus. I want to give you my story of how I got into this field because, as Jose said, I'm a pretty young guy. I'm 27. When you're in your mid-20s, you don't really, am I in my late 20s or mid-20s at 27? I'm not really sure. But in your 20s, you don't really think about longevity too much. And when I talk to my friends from college and high school, they kind of look confused when I talk about my interest in the longevity space. So I'm going to tell you my background. And I think that's a very important thing to convey, for all of you to convey to people you talk to about this space. I got interested in the longevity space when I was about 13 years old. My father, who Jose also knows, is an investor in next generation technologies. And he was driving me to school one day, and he pulled up a video and he said, "Look at this guy I met at this conference. This guy is outstanding. I think you might know who this guy is. He's got a very long beard. I think he spoke earlier today. Kind of looks like a wizard. His name is Aubrey de Grey, and he was talking about the quest to defeat aging." And as a 13-year-old, you kind of look at him and you say, wow, what's this guy up to? I want to know more about what he's thinking about. But you don't really think about aging at 13 years old, right? It's more of like this distant thing. You don't really have the cognitive abilities to even comprehend what it means to age. Fast forward a couple years, I kind of buried that whole world in my mind, and then COVID hit, and I think the ravages of aging were very apparent to all of us. I'm sure everybody in this room probably had someone that they knew that were afflicted by COVID, probably of an advanced age, and that kind of changed my thinking about life. It changed the way I looked at the future. It changed the way I looked at politics and health and life in general. And I remember being locked in my parents' basement and really kind of depressed about the prospects of getting older. And I realized that I knew about this guy who my father showed me when I was 13 doing something about it. He was trying to advance the cause to slow, stop, and eventually cure aging. And that really inspired me to take action. At the same time, I was working in politics. I was working for the Democratic National Committee. And I eventually went on to work for Joe Biden's campaign in Pennsylvania. And what I realized after listening to a number of the influential speakers in the space talk and reading books and et cetera, was that there was no voice for this community on Capitol Hill. And there were a number of things that needed to change if we wanted to see real progress in this space. And so I don't know if this was bravery or complete delusion, but at the ripe age of 23 years old, I decided to take on this mission myself and create the voice for the longevity industry in DC. So that's my backstory, and I encourage all of you, when you talk to people that are not, fully, us Gen Zers say longevity pilled, when you haven't taken who's seen The Matrix? I'm sure some of you have seen The Matrix. For people that haven't taken the longevity pill, I think it's important to lead with your backstory, because this is a very personal issue for all of us. And at the end of the day, we're doing this not only for ourselves, but for the people that we love. And we want to convey that to as many people as possible, because this is the greatest humanitarian mission of all time. The Alliance for so that's my backstory. After I made this realization, I went on to create the Alliance for Longevity Initiatives. We've been around, as you can see, for about 3 years now. I have another slide about this, but I'll kind of go into it now and kind of talk about some of the things that we've done over the last 3 years. The first thing we did as an organization is we established a congressional caucus in the House of Representatives, so a special interest group in the House of Representatives, to advocate on behalf of the longevity industry. And so I'm very proud to say, I like to pat myself on the back for this. It's a bipartisan group of lawmakers. You go to Washington, you tell me what other things are bipartisan, nothing, right? But the quest to live healthier and longer is one that brings people together, and that's very touching and encouraging to see. We also passed a series of laws in Montana. So I don't know how many of you are familiar with that small state in the middle of the country in the US, but Montana, that expands eligibility under the Right to Try Act. So Right to Try was a law that was passed in 2017 by the Trump administration that allows patients with terminal illnesses to try therapeutics that haven't been fully approved by FDA. That is a great law. It's a no-brainer, right? If you are on your deathbed, you obviously should be able to try and exhaust every option and avenue to make yourself healthy again. But that doesn't fully jive, in my mind, with the longevity industry's and community's mission here, right? We want to be preventative and proactive with our health. And so what the laws that we passed do are open up eligibility under this Right to Try law to healthy patients as well. And so now if you're a healthy patient and you want to go try the latest senolytic or mitochondrial dysfunction drug, et cetera, you can go to Montana and you actually have access now. And that's very exciting. I came at this, from looking at people traveling abroad to places in Central America and Eastern Europe. And I saw that people were going abroad to get these experimental treatments. And I figured, why not do this in America? We're losing out on economic opportunity, data collection, et cetera. And so I think kind of centralizing that in the US is a very beneficial thing for the field, and we can accelerate the developments of longevity medicine in a major way by having Montana as this state. So now I'm actually going to get into my talk. That was all like the intro stuff. Now let me get into the talk. So the economics of longevity. Why is this the greatest opportunity, the greatest problem and the greatest opportunity in the history of humanity? So the first thing is, there you go. The world is getting older and sicker. I think all of you probably know this. You look around. I've been in Madrid for a couple days now. I've seen far more people above the age of 65 than I've seen under the age of 18, I would say. It's very obvious just by looking around, but the statistics show that our world is getting older and sicker as well, right? You're not supposed to be able to read all of this, by the way, don't even try. But what I want to really convey to you on this chart is even in the healthiest countries, so we all think of Japan and Switzerland and Australia as being very healthy countries. Even in these places, people live about 12% of their lives in really poor, debilitating health. If you look at my home country, the US, where I'm a little embarrassed about that. We have the longest sick span in the entire developed world and the shortest health span in the entire world, so I'm obviously trying to fix that. But these numbers actually have implications for how society runs. In America, I can speak specifically about America, but in America, we have a growing deficit problem, and that's really driven not by expenditures by the government to USAID. It's really driven by the fact that Medicare is continuously being sucked up by our elderly population, and that's going to continue to grow unless something changes. The thing that can change this Medicare projection right here is the advent of longevity medicine. And so that's why I'm so passionate about developing and putting money towards developing these therapeutics and these drugs for our older population and our younger population. If we nip this in the bud now, then these numbers, the $1.8 trillion, will be curbed, and Elon Musk won't have to take a chainsaw to all the government programs. The issue, though, in the United States, and the United States is actually sort of leading the way, but not leading the way enough in the development of longevity biotech. The issue is America doesn't really spend enough money on the biology of aging. So we have a budget in the NIH, with the NIH, of about $40 billion a year. The Division of Aging Biology gets less than $400 million a year. So less than 1% of its budget goes towards this issue that drives 90% of disease and death in America. It's a complete misallocation of funding, and that's part of the work that A4LI does, is explaining this to appropriations committees, to energy and commerce committees, et cetera, that this is a problem that needs to be focused on and fixed. So opportunities. So how many of you here have heard about the longevity dividend? Raise your hand. Not that many. Are you just being shy, or? Okay, I don't know. But the longevity dividend, if you're in the longevity field, this is something that you should be very aware of, because this is, in my opinion, the most compelling economic argument for the longevity industry. There have been a number of studies over the past couple of years showing what the implications would be if we extended healthy lifespan in our population, and what would that mean for our economic value. Like I said, there's a number of them. They don't show exactly what I'm showing you here, but this is my favorite economic analysis of the longevity dividend. This was done by Andrew Scott and David Sinclair, who I'm sure all of you know. And it showed that even 1 year of healthy life extension in a population would equal $37 trillion of GDP gains. $37 trillion is about 110% of what the US economy is right now. And, you know, that's just for 1 year, right? So if you kind of scale it up, they show that if we can increase the average healthy life expectancy by 10 years, then we gain potentially several hundreds of trillions of dollars in GDP gains. And where does that come from? Obviously, it comes from, people being more productive, right? If you are not sick, then you can contribute to society in a more meaningful way. You can work, you're economically productive, but then you're also contributing to society by going out and spending money and increasing GDP gains that way. On the flip side, I was talking before about Medicare. We're not spending as much if people are healthy on keeping people alive in a sick state, right? So this is where the economic analysis comes from, and it's very compelling, especially when I go talk to politicians. This is the thing that they care about the most. They like the moral aspect of it. I like the moral aspect. We all want to live healthier longer, but they care about getting reelected. They care about, showing that their specific constituent district is doing a good job and job opportunities, et cetera. And so this is the thing that really resonates the most with politicians. And if you ever speak to a politician, I highly recommend bringing up the longevity dividend. And so this is another slide here. I basically just said all of this, so I guess I can skip. Our solution to getting the longevity dividend implemented in America and the world is by lobbying, right? The government has a lot of levers at its disposal that it can pull to ultimately yield the longevity dividend for its population. Right here, you'll see, I gave some back of the napkin math here on what other industries spend on their lobbying efforts and the returns that they get. So the Alzheimer's Association, which is the major Alzheimer's industry association in DC, they put about $4 million into lobbying back in 2024. 2024, mind you, was a continuing resolution year, which means that there was really no changes in the budget bill. But they still ended up getting a $100 million increase in Alzheimer's research. That's a 25x ROI, right? If you put money into the stock market and you got a 25x ROI, you'd be pretty happy. Military contractors are even greater than that. They spend about $145 million on lobbying, and each year the Pentagon shells out $431 billion in contracts for the military industry, right? And so you see, obviously in yellow, I wanted to highlight this point. The more we put in, the more we are going to get out of the government. But we need support, we need engagement from all of you in America and beyond to really get the most out of our governments for this issue. I mentioned it, we did a bill in Montana earlier this year, SB 535, and I kind of wanted to give that as a guide. So we spent about $60,000 on getting this bill passed through lobbyists, through advocacy materials, et cetera. You can obviously see at the bottom, Montana is a population of 1.1 million people. If you scaled that up to the US's population, and then you scaled up the amount we spent in Montana, if we spent $20 million as an industry on lobbying, we would get the same return of value from the federal government, right? So again, very back of the napkin math here. I'm not a mathematician, I'm a politics guy, so I'm sure there's mathematicians out here. Don't roast me, all right? But this is the kind of framework that I'm thinking about. And if we can put substantial money into this, but not too substantial. We don't need $20 million is a reasonable Series A raise for one biotech company. If we can put this into lobbying, these are the kind of returns that we get. So I spoke a little bit about our accomplishments. I think I messed up and I put this slide at the end. I'm sorry about that. But you'll see me here at our DC summit last year with Dr. Oz, who's the director of the Center for Medicaid Services, with Dr. Mike Roizen from the Cleveland Clinic, and then on my left is Congressman Gus Bilirakis, who's our Republican co-chair for our Longevity Science Caucus, and Congressman Paul Tonko, who's the Democratic co-chair. So my ask to all of you is two things. One, get involved, right? Your voice matters when you're talking to politicians. This is the ultimate issue. This is the ultimate humanitarian issue that the entire world needs to take, focus on. Otherwise, we're screwed. We're just genuinely screwed. Our social systems, our economic productivity is going to collapse because we're going to have too many old people that are reliant on the system, right? So this is the ultimate humanitarian issue from a moral standpoint, but also the ultimate economic issue that we need to be driving as a group. The longevity industry is, still very new, but we're growing, right? I think there's a good amount of people here, and every time I go to a conference, there's more and more people. And so talk to your friends, talk to your politicians, talk to people with power, because this really matters. And then the second thing, my second ask for you is get involved with us at A4LI. We need your support. Like I said, I don't know if we'll be able to raise $20 million here, but if we want to get, a reasonable return from the government, we need to raise money, spend it on lobbyists, spend it on policy development, and actually, come together as a community to push this forward. So I guess that's it. That's all. Is that good, Jose? All right, perfect. Thank you. Thank you, everybody.
Thank you. Thank you so much, Dylan. And it's good to see what he's doing in the USA. This is fantastic because if we get this legislation approved in the USA, we don't have to go to other places. So anyway, fantastic, fantastic.